Geotrig, this is lesson, I think this was what, lesson 40? This is lesson 40 of the log stuff, so we can continue into the log packet. This is the last one we talked about, or the first rule, and it was the sum of logs. So there are three laws. We did the first one the other day, and it says that if I have two logs, I'm sorry, not two logs, well, it can be two logs. It goes both ways, guys. That if I have a log of a base of two things being multiplied, I can separate them to the same base, log base, but add the logs together. But this also works in the fact that I can see it as two logs with the same bases being added. I can put their numbers together and multiply. So this goes both ways, okay? So what we're going to do today is we're going to do the others. So there's also a law is called the difference of logs here. And that difference of logs says kind of the same thing. I have log base b, but instead of multiplying, you are dividing. And if you divide logs, you can separate them to their own log with a minus sign between them. Okay? And the vice versa. If I see two logs with the same base being subtracted, the one that is being subtracted will go underneath. You divide them. You divide the numbers. So m divided by n. And I can write them as a single log. I don't know if I said this last time, but when I'm going from a single log to multiple logs, that's called expanding. If I'm going from multiple logs like this to a single log, that's called condensing. So you're either going to condense the logs or you're going to expand the logs to solve equations. Hence, we have something below where we need to solve it. But to solve logs, we cannot, in this case, just divide by a log, base 4. That does not work. But what does work is the fact that, hey, wait a minute, this is the same log base 4, log base 4. They're being subtracted. So therefore, it's log base 4 of x plus 6 over x minus 1 equals log base 4 of 5. And here's a really cool thing. Log base 4 of something equals log base 4 of something. I totally lost the whole x plus 6 over x minus 1 and 5. I changed it. I left this out, and I said something. And I took the 5 out and said something. Is because the only way for a log base 4 of a number to equal a log base 4 of another number is if those two numbers were the same. So in this step, at this point, you're like, wait a minute. I basically can cancel the logs out and say, when does x plus 6 over x minus 1 equal 5? And can you solve that? And you guys should be saying, yes, I can. I can solve that. How do I solve that? Multiply both sides by x minus 1. Because the x minus 1s will cancel. Leaving you with, I'll move up here, x plus 6 equals, can I distribute that while I'm at it? 5x minus 5. Subtract x. Add 5. 11 equals 4x. Divide both sides by 4. So x is equal to 11/4. You're done. And if you're not sure, check it. It should work. Not too bad. But we had to condense a little bit, and we had to cancel out the logs because we had a log of the same base equaling another log of the same base. And the only way for those two logs to be the same is if all their parts were the same, right? So it works out wonderfully. The last law is called the power rule. The power rule states that if you have a log base b of m, and m happens to have an exponent on it, that exponent actually can go out front. And that's why n is out front here, and it's n times the log base b of m. Again, if I'm going from the condensed to expanding to the expanded version, that's expanding. And if I go to the left, I'm condensing. That's kind of what they're showing here. It goes both ways. Okay? Now, what we're going to be given equations that we have to solve. And you're like, hey, look, there's a log base b on this side, log base b on that side. That's great, but again, it only works if it's log base b of something equaling log base b of something, not 3 times one of them equals another one. So to make this happen, we need to get that 3 out of there. So how do I get that 3 out of there? Okay, if I divide by 3, then it ends up on this side. So maybe that's not the best option. So I need to take care of the 3. Since it's multiplied to a log, I can move it as an exponent. So this becomes log base b of x to the 3rd power equals log base b of 8. If that's true, what would have to be true about those things? For them to be the same. Do I need the log base b's anymore? So they're gone. So therefore, when does x cubed equal 8? When x equals 2. Or, what's the official way to solve that equation? Take the cubed root of both sides. Right? Cubed roots only have one solution. So, I want you guys to take the time and solve log base 12 of x equals 2/3 log base 12 of 64. What's my first move? What should I do? Right. Move the 2/3 to an exponent position on 64. And at this point, take the logs, get rid of them. So x is equal to 64 to the 2/3. How do you know it's 16? Because you put it on your calculator. How can we do this without a calculator? It is 16. You guys remember how to do this? Ooh, not square root of 2. You can multiply, divide. What if I said there's a power of power going on here? Don't you guys remember that this can be written as 64 squared to the 1/3? Would you guys be okay with that? Power of power says I multiply the exponents. That's 2/3. Or that's 64 to the 1/3 squared. Either one of those will be the same as 64 and 2/3. 64 to the 2/3, sorry. Can we agree with this or not agree with this? I hope we all agree with this. The question is, How many of us know right off the top of our head? What's 64 squared? Anyone? Anyone? Yeah, I don't know that either, okay? Don't expect you guys know. So I don't know if I would do that and then have to take the cube root of it. That's a really big number. But would I expect you to know the cube root of 64 without a calculator? I think, yeah, that's approachable. That seems legit. Why? Because what does it mean to be a cubed root? It means what times itself 3 times would make the number that we're taking the cube root of. What times itself 3 times is 64? Other than Jake, who used to use his calculator. Jason? 4. 4 times 4 is 16 times 4 is 64. And so therefore, if I use this one, it's 4 is instead of a cubed root of 63 squared, and 4 squared is 16. 16 is the appropriate answer for that problem. Okay, to give us more practice here, using all 3 laws, I want you to expand. And I think I may have spelled condense wrong. Condense the second expression down below. Now, I'm going to tell you this. There are the 3 laws that we talked about. So, the reason I have to do these more examples is because you have a whole entire worksheet on condensing. And it's just the opposite of expanding. I couldn't find an expanding worksheet like those. But here's the thing, is I like to think of traveling in a car. I know this summer, my father-in-law is taking us all to Florida. And so, we're all going to end up staying in the same place, bless you. And this is what's going to happen. We're going to drive. So when you go take a family vacation, whether you're going to your cabin, going to wherever you're going in the car, the biggest thing is everybody in the family, especially at this age, right, everybody goes and packs their own bags. Yes? So let's think of those 3 laws. Now, I'm going to change the page again. I'm going to write down those 3 laws. Okay, so we've already talked about these 3. And now, we're on this trip. This is how I like to think of it. When you are going to pack to a car, you got to condense. Yes? And so, individually, everybody needs to pack first. So, when we are condensing, you're going to go from a bottom-up approach. You, as an individual, need to take your luggage and you need to carry it. Okay? Everybody kind of gets that analogy? So this 3rd step is like the individual. They're going to take their stuff and they're going to pick it up and carry it. Then we can go back to steps 1 and 2, which is actually trying to get into the car. Now everybody's got to get into the car. And now everybody takes their individual stuff, which now looks like this, and they're going to condense them into the car. If you are a positive log of the same base, you get to go to the top. If you are a negative in front, like this one, you end up going to the bottom. So it doesn't matter if I string 50 of these together. The ones that are positive go to the top and they all get multiplied together. Anything that has a negative in front will go to the bottom and be multiplied together. Okay? So let's go back. Try the condensing one first, because that's what we just talked about. Okay? Try this condensing one first. I'm going to pause it, come back to it. Okay, so the first step, again, is using that rule number 3 in reverse, which means I need to take 2 and move it up, right? And I need to take the negative 1/2, and move it up. Now the question that came up was, do I move 1/2 or do I move a negative 1/2? So let's do this first part first. Log base 3 of x squared plus log base 3 of x plus 1. So then we're going to decide. I'm going to tell you guys, leave the sign alone. Leave the sign below. Take the number and move the number. This will allow me to keep my exponents positive. And anytime I have positive exponents, I'm usually pretty happy. Okay? It's when I have negative exponents, like I explained, that then you have to move them from where they're at. And so if I keep them positive, we're happy. And from here, now I can apply the rules from number 1 and 2 that says they're all going into the car, the same car. The same car is going to be log base 3. So I'm going to have a bigger set of parentheses here. The ones that are positive get multiplied. That's an x squared and x plus 1. What goes in the bottom? Y to the 1/2. And you now have condensed this. Now, if I had to be really picky, what are some things that you should probably do to make that a little bit better? Some of it may be putting the x squared and x plus 1 together. Maybe. But y to the 1/2 power, maybe we should change that too.
I feel like y to the first one is square that.
No. 1/2 power means something different.
What is the negative though?
The negative is what brought it to the bottom.
Oh.
Right? Because if I took the negative, guys, and I'll change colors. That if I had made this a positive and left the negative here, then we would have been writing y to the negative 1/2 up top, right? This wouldn't be here.
Oh, okay.
But if that's the case, we don't like negative exponents, so therefore, whoop, it would end up on the bottom anyways. That's what I was trying to say. Both ways will get you there, but one probably is a little less work. Okay? So, remember, what does something to the 1/2 power mean? What's 25 to the 1/2 power? It's not half of 25. It's 5. It's the square root. So you might want to change the 1/2 power to the square root of y. Stuff like that. Now, any questions on that? You got a whole worksheet of just doing that. Condensing. The one thing I couldn't find was the expanding part, but it's the exact opposite. So, now, let's go back to our analogy. Going back to our 3 rules. We just made it to our destination. We're all in the car. We've been next to each other for 24 hours. We don't want to be next to each other anymore, yeah? So therefore, everybody runs out of the car. Using steps 1 and 2, everybody gets out of the car. They unpack out of the car, right? Then, once you get to the hotel room or wherever you're staying, you individually can take the stuff out of the car, or you kind of unpack, right? I don't know if that kind of helps the situation. So when I'm expanding, you start from 1, 2, 3. When you're condensing, you go 3, 2, 1, or 3, and then 1 and 2. It doesn't matter. 1 and 2 can be done in any order, but 3 is either first or it's last. Think of it going on a trip. If you're going to condense down, pack, you need to do things individually. Do number 3 first. If you're going to expand, take things apart, well then you got to get out of the car. That's the last thing you should do, is take everything out. Unless you're one of those people, like my daughter, who's in the back seat and has everything out. Don't be like that. So, try that first problem now. Okay, what's the first line going to look like? Okay, log 2 x squared plus y to the 3rd minus z. That would be step 1. Everybody just got out of the car. Now everybody can take all of their stuff and set it down. So what's the next step going to look like if everybody sets their stuff down?
I thought that was
2 log 2 of x plus 3 log base 2 of y minus log base 2 of z. You should be able to go from this step to this step, or that step to that step. That's a condensing, expanding, condensing, expanding, condensing, expanding, condensing, expanding. You should be able to do that. Your homework is worksheet number 2, the baby astronaut one, and worksheet number 3, tick tock.